Hello, my dear friends, and let's start our lecture number 2 on airplane control. And let's start our lecture with the answer for the quiz you have on the previous lecture number 1. Okay? So let's do it. First question was, how can you avoid spatial disorientation when flying in IMS? The correct answer is by believing the flight instrument. Question number 2 was, flying visually in a clear blue sky above a sloping cloud layer may not be as easy as it sounds. Why? Because a sloping cloud layer may cause a false horizon. Example. Third question was next. You are flying over a well-lit town situated on sloping ground. What sort of visual illusion could you experience? And correct answer here, a false horizon. Next question, how can you assess the adaptation of your eyes to darkness in the cockpit at night? The correct answer, by avoiding bright white light in the cockpit. And final question, if you do not refer to your flight instrument, what sort of illusions or sensations can result from the following? And you have 4 questions, A, B, C, D here. You can read about someone. I only commented the answer. Answer for A, the illusion of tumbling backward. And answer for B is C, the illusion of being in a nose-up attitude. And answer for D, the spatial disorientation. Okay? And today we have lecture number 2. The topic of this lecture, instrument scanning technique. You know, the 3 fundamental skills in instrument flying are its instrument cross-check or scan, instrument interpretation, and airplane control. In this lecture, we look at suitable flight instrument scanning techniques that allow you to cross-check the instrument efficiently and to extract and interpret information relevant to the flight path and performance of your airplane. The performance of an airplane is, as always, determined by the power set and the altitude selected. In visual flying conditions, the external nature of horizon is used as a reference when selecting pitch, altitude, and bend angle. The power indicator in the cockpit is only referred to occasionally, for instance, when setting a particular power for cruise or for climb. In instrument conditions, when the nature of horizon cannot be seen, pitch, altitude, and bend angle information is still available to the pilot in the cockpit from the altitude indicator. The pitch altitude changes against the nature of horizon and reproduced in miniature on the altitude indicator. In straight and level flight, for instance, the beams of the miniature airplane should appear against the horizon line, while in a climb, they should appear 1 or 2 bar width above. In a turn, the wing bars of the miniature airplane will bank along with the real airplane, while the horizon line remains horizontal. The center dot of the miniature airplane represents the airplane's north position relative to the horizon. Today, there are a variety of altitude indicators you might see. Some are referred to as primary flight display (PFD). In any display, the principles remain the same. The center dot or center point position relative to the horizon indicates a climb or descent. Let's start with the first question of this lecture, scanning the instrument. Scanning the instrument with your eyes, interpreting their indications and applying this information is a vital skill to develop if you are to become a good instrument pilot. Power is selected with the throttle and can be checked, if required, on the power indicator. Pitch attitude and bank angle are selected using the control column with frequent reference to the attitude indicator. With both correct power and attitude set, the airplane will perform as expected. The attitude indicator and the power indicator, because they are used when controlling the airplane, are known as the control instrument. The actual performance of the airplane, once its power and attitude have been set, can be cross-checked on what are known as the performance instrument. The altimeter for altitude, the airspeed indicator for airspeed, and the heading indicator for direction, okay? And so on. A valuable instrument, important on its own right, is the clock or timer. Time is extremely important in instrument flying. The timer is used in holding patterns, which, for example, may be racetrack patterns with legs of 1 or 2 minutes duration, or maybe in time turns 180-degree changes of heating at standard rate of 3 degrees per second, taking 60 seconds. And to measure time after the passing setting radio fixes during instrument approaching. Like at 90 knots ground speed, for instance, it would take 2 minutes to travel the 3 nautical miles from a particular fix to the published missed approach point. Another area on the instrument panel contains the navigation instrument, which indicates the position of the airplane relative to selected navigation facilities. These navaies will be considered in detail a bit later in your training, but the main ones are VHF Omni Range or VOR cockpit indicator, which indicates the airplane's position relative to a selected course to or from the VOR ground station. Automatic Direction Finder ADF, which has a needle that points to a non-directional beacon, NDB, and Distance Measuring Equipment, DME, or TAC, which indicates the slant distance in nautical miles to the selected ground station. Instrument scanning is an art that will develop naturally during your training, especially when you know what to look for. The main scan to develop initially is that of the 6 basic flux flight instruments, concentrating on the AI and radiating out to the others as required. Then, as you move on to en route instrument flying, the navigation instruments will be introduced. Having scanned the instrument, interpreted the message that they contain, built up a picture of where the airplane is and where it is going, so you can now control it in a meaningful way. Let's start the next question, scanning the instrument in a glass box. Now, the introduction of computer screens into the cockpit, sometimes referred to as a glass cockpit, and has changed the look of the general aviation flight deck, but not the function of the flight instrument. Both the traditional round-tile flight instruments and the glass instruments deliver the same information to the pilot, yet the presentation may be different. The traditional round tile placement of the instrument has been called the sixth part. Left figure is a photograph of the six basic instruments. Much thought went into these instruments should be placed for maximum efficiency. The primary flight display of PFD over glass cockpit also has a six pad. See the right figure. And compare the traditional six-pack in the left here with the PFD on the right figure, please. On both panels, the airplane attitude is displayed in the center. The round attitude gyro is top center in the most prominent position. The airplane's attitude is also displayed prominently on the PFD, with an illustration of the horizon crossing the entire screen. The round airspeed indicator is located on the upper left of the six-pack. The airspeed indicator is also on the left of the PFD, usually at the middle figure. The airspeed displayed on the PFD is a vertical tape that uses the proper color code. The round altimeter and the vertical speed indicator are on the right side of the traditional panel, and they are also on the right side of the PFD, figures middle and right. The round heating indicator is placed at the lower center of the six-pack, and likewise the electronic image of a round heating indicator is located at the lower center of the PFD. The six-pack remains virtually intact whether the presentation is mechanical round tiles or an electronic computer screen. So let's start next question. It's very simple. Simple count. And let's start with the heating. You know, directional information can be obtained from the heating indicator, HI, or from the magnetic compass. From the AI, the eyes can be moved straight down to the HI heating indicator to absorb heating information before returning to the AI. Each eye movement to obtain information is very simple, starting at the attitude indicator and radiating out to the relevant instrument before returning to the AI. Next, airspeed. Airspeed information is also very important, and this is easily checked by moving the eyes left from the AI to the airspeed indicator before returning them to the AI. Altitude. The altimeter is the only means of determining the precise altitude of the airplane in visual as well as in instrument condition. To obtain altitude information, the eyes can move from the AI towards the right where the altimeter is located before moving back to the AI. Vertical speed. The rate of change of altitude, either as rate of climb or rate of descent, is feet per minute and can be monitored on the vertical speed indicator, VSI, by moving the eyes from the AI diagonally. You look please in this slide. Down to the right to the VSI before returning to the AI. The VSI, since it is often used in conjunction with the altimeter, is located directly beneath it on most instrument panels. Coordination. The AI, while it shows pitch attitude and bend angle directly, does not indicate coordination or yaw. Coordination, or sometimes called balance information, can be obtained simply by moving the eyes from the attitude indicated diagonally down to the left, to the inclinometer, to check that the ball is indeed being counted with the rudder pressure. The eyes should then return to the AI. Turning. A turn is entered using the AI to establish the bend angle and the inclinometer ball to confirm coordination. Additional information on the turning rate is available from the turn coordinator once the bend angle is established. The normal rate of turn in instrument flying is 3 degrees per second, known as a standard rate. And this is clearly marked on the turn coordinator or turn and slip indicator. With these 6 basic flight instruments, plus the power indicator, it is possible to fly the airplane very accurately and comfortably without any external visual reference, provided the instruments are scanned efficiently. Your control the airplane is a response to the information derived from them. The better you scan, the more rapidly you get information, and the better you control the aircraft in instrument conditions. Okay? So, let's come to the next question today's lecture: control and performance. The attitude selected on the AI by means of the flight control and the power set on the power indicator by means of the throttle determines the performance of the airplane, and hence these 2 instruments are known as the control instruments. The attitude indicator is located centrally on the instrument panel, directly in front of the pilot, so that any changes in attitude can be readily seen. Because continual reference to the power indicator is not required, it is situated slightly away from the main group of flight instruments, easy to scan or occasionally, but not in the main field of view. The other flight instruments are performance instruments that display how the airplane is performing as a result of the power and attitude selected in terms of attitude on the altimeter and VSI, direction on the HI and turn coordinator, and airspeed on the ASI. Changes in pitch attitude are shown directly on the AI, and the change in an aircraft performance is reflected on the altimeter, VSI, and ASI. Changes in the bank angle are shown directly on the AI and are reflected on the turn coordinator and the heading indicator. This coordination of finesse of flight is shown by the coordination ball. In other words, the bank angle is an input. The turn coordinator is an output. It indicates the resulting rate of turn. Okay? Next question today's lecture: the selective radial scan. Of the 6 main flight instruments, the attitude indicator is the master instrument. It gives you a direct and immediate picture of pitch attitude and bend angle. It will be one most frequently referred to, but maybe at least once every few seconds in most stages of flight. The eyes can be directed selectively toward the other instruments to derive relevant information from them as required, before being returned to the AI. This eye movement radiating out and back to selected instruments is commonly known as the selective radial scan. For instance, when climbing with full power selected, the estimated climb picture attitude is held on the attitude indicator with subsequent reference to the airspeed indicator to confirm that the selected pitch attitude is indeed correct. If the ASI indicates an airspeed that is too low, then lower the pitch attitude on the NI. It may be, say, by a half bar width or by 1 bar width. Allow a few seconds to the airspeed to settle, and then check at the ASI again. The primary instrument in confirming that the correct attitude has been selected on the AI during the climb is the airspeed indicator, because it determines what pitch attitude changes should be made on the AI during the climb. The airspeed indicator is the primary performance guide for pitch attitude in the climb. It is supported by the AI and the VSI. Approaching the desired cruise attitude, however, more attention should be paid to the altimeter to ensure that as pitch attitude is lowered on the AI, the airplane levels off right on the desired altitude. When cruising, the altimeter is the instrument that determines if pitch attitude changes on the AI are required to maintain level flight, and the altimeter is the primary performance guide for pitch attitude. Any minor deviation from attitude detected on the altimeter can be corrected with small changes in pitch attitude. It is supported by the AI and the VSI. If climb power is still set after the airplane has been leveled off at cruise altitude, then the airplane will accelerate, and shown by the increasing airspeed on the ASI. At the desired speed, the power should be reduced to a suitable value. While the pilot may simply set cruise power and then accept the resulting airspeed, it is possible to achieve a precise airspeed by adjusting the power. Because the ASI indication will then determine what power changes should be made during level of flight. The airspeed indicator is the primary performance guide to power requirements in the cruise. Heading is maintained with a reference to the heading indicator, HI, heading indicator, and any deviation corrected with a gentle coordinated tone. Because the indication on the HI will determine what minor corrections to bend angle should be made on the attitude indicator during straight flight. The heading indicator is the primary performance guide to the zero bend angle in maintaining a constant heading for straight flight. It is supported by the tone coordinator and the AI. The ball should be centered to keep the airplane from slipping or skidding to provide coordinated straight flight. Okay, next question, the basic T-scan. A basic scan suitable for the straight and level flight, usually where altitude, direction, and airspeed need to be monitored, is centered on the AI and radiates out and back, following the basic T pattern on the panel to the relevant performance instrument. That instrument name, the HI, to confirm heading and correct with shallow tones on the AI. The altimeter, to confirm altitude and correct with speed changes on the AI. And the ASI, to confirm airspeed and, if desired, correct with power changes. If cruise power is set and left alone, and the resulting airspeed accepted, normally the case, then scanning the ASI need not be as frequent, and the scan can concentrate on the AI, HI, and altimeter. Also, once established and well trimmed on the cruise, the airplane will tend to hold altitude because of its longitudinal stability, making it less essential to scan the altimeter continually compared to when the airplane is out of trim. The airplane may not be as stable laterally as it is longitudinally. However, and so the HI should be scanned quite frequently to ensure that the heating is maintained. Visually, pilots are already well practiced at scanning the altimeter regularly, since it is the only means of accurately holding altitude. But they may not be used to scanning the HI quite so frequently as it is necessary in instrument conditions. This skill will have to be developed. Okay. Next question, sub-question. What about the other flight instrument? Right? In smooth air, the VSI will show a trend away from cruising altitude, often before it is apparent on the altimeter, and can be used to indicate that a minor pitch altitude correction is required if altitude is to be maintained. Now, the VSI provides supporting pitch information to that provided by the altimeter. Also, it is of less value in turbulence, which causes the VSI needle to fluctuate. If the winds are held level on the AI and heating is being maintained on the HI, then it is almost certain that the airplane is coordinated, in balance, with the inclinometer pole center. Normally, the inclinometer does not have to be scanned as frequently as some of the other instruments, but it should be reflected to occasionally, especially if heating is changing while the winds are level, or if the seat of your pet tells you that the airplane is heating or sleeping. The turn coordinator will show a wings level indication during the straight flight and provides supporting information regarding bend to that provided by the heating indicator. In a standard rate turn, it is the primary performance guide to confirm that the bank angle is correct. Okay. Next question. Choice of scan path. Starting with your eye, focus on the AI, scan the performance instrument that provides the information required. Relevant information can be obtained from the different instruments depending on the manual. Primary pitch information to confirm whether or not the pitch altitude selected on the AI is correct is obtained from the altimeter during cruise flight, but from the ASI during constant airspeed climbs and descent. There is no need to memorize particular scan patterns, since they will develop naturally as your training progresses. Do not allow the radial scan to break down. Avoid fixation on any one instrument, since this will certainly cause a breakdown in the radial scan and result in delayed recognition of deviation from the desired flight path, and or airspeed. Fixation on the HI, for instance, can lead to heading being maintained perfectly. But in the meantime, attitude and the airspeed may change, tendencies which would have been detected and corrected for if the altimeter, VSI, and ASI had been correctly scanned. So keep the eyes moving and continually return to the AI, okay? Occasionally, the eyes will have to be directed away from the main flight instrument for a short period. For instance, when checking the power indicator during or following a power change, or when periodically checking the oil temperature and pressure instrument, the ohmmeter, or the suction vacuum gauge, realiging the heading indicator with the magnetic compass, referring to instrument approach chart, filling in the flight log, or tuning radio. Do not neglect the radial scan for more than a few seconds at a time, even though other necessary tasks have to be performed. Avoid omission of any relevant instrument. For instance, after rolling out of a turn, check the HI to ensure that the desired heading is being achieved and maintained. The wings might be level and the airplane flying straight, but on the wrong heading. Use all available resources. For instance, with correct power set and the correct attitude selected on the AI. In this case, it is possible to hold altitude approximately, using only the AI and the power indicator. But if precision is required, then the altimeter must be included in the scan as the primary reference for altitude. And finally, remember the supporting instrument can provide additional information to back up primary instrument. For example, altitude is indicated directly on the altimeter, but any tendency to depart from the altitude may first be indicated on the VSI, especially in smooth air, which makes it a very valuable supporting instrument to the altimeter. The bottom line of the scan is simple. Keep your eyes moving, okay? And other scans, next question. It is necessary on some occasions to have a fast scan, such as on final foreign instrument approach. On other occasions, however, the scan can be more relaxing. For instance, when cruising with the autopilot engaged. It may then be suitable just to have a fairly relaxed circular scan. If you are performing other tasks while flying a constant heading, such as chart reading, then a very simple scan to make sure things do not get out of hand is a vertical scan from the AI down to the heading indicator and back again. Okay? If at any time your suspect has an instrument failure, then a very efficient means of establishing what instrument or system has failed is to commence with an inverted V scan centered on the AI and radiating to the tone coordinator and the VSI. Each of these instruments normally has a different power source. The vacuum system for the AI, the electrical system for the tone coordinator, and the static system for the VSI. So as a false indication on one should not be reflected on the other. Confirmation of attitude and flight path can then be achieved using the other instruments when tuning. Otherwise, it is not seen, right? And finally, the VSI remains in its usual place, below the altimeter. It may be part of the altimeter section of the glass panel and may appear only when climbing and descending. One final note on scanning the new instrument. The glass cockpit instrumentation provides both a needle and the digital value. And thus, you have two indications of altitude or rate of climb and descent, an analog or needle indication, and a digital readout of a discrete value. This is a small investment of time to learn the new instrument presentation. You will find them easy to scan and interpret, and thereby you to maintain a smooth level flight on course. And now let's start our second quiz. After each lecture, we will have a quiz. Okay? So let's start. Instrument scanning techniques. We have here 4 questions. First, what are the 3 fundamental skills in instrument flying? Second, sketch a simple diagram showing the relative positions of the 6 main flight instruments. Third, what is the master instrument for pitch, attitude, and bend attitude? And fourth, which instrument provides directional information? Prepare your questions, answer for this question, and next lecture, for beginning, I'll show you the correct one. Okay? Let's go on. Next question, serious question, question number 5. Which device indicates whether or not flight is coordinating? Question number 6. Which instrument provides airspeed information? 7. Which instrument provides altitude information? 8. Which instrument provides vertical speed information in terms of rate of climb or rate of descent? Okay, next serious question. Number 9. Changes in pitch attitude are shown directly on which instrument? Which instruments reflect these changes? 10. Changes in bend attitude are shown directly on which instrument? And which instruments reflect these changes? 11. What term is used to describe eye movement radiating out and back to selected instrument? And 12. All changes of pitch attitude and bend angle should be made with reference to which instrument? Next serious question, number 13. In level flight, which instrument is used as a primary performance guide to confirm that the pitch attitude selected on the AI is correct? And which instrument supports this? Question number 14. In climbing flight, which instrument is the primary performance guide to confirm that the pitch attitude selected on the AI is correct? Which instrument supports this? 15. Which instrument will indicate any need for a power change for cruise at a specific airspeed? 16. Which instrument is the primary performance guide to confirm that the bend angle selected on the AI is correct for a standard rate term? Next serial questions in the next slide. Question number 17. Which instrument is the primary performance guide to confirm that the wings are level? 18. Sketch a simple diagram showing the relative positions of the instrument that provide pitch information. 19. sketch a simple diagram showing the relative position of the instruments that provide bank information. And next, question number 20. Assume you are under radar control with approach control and are instructed to turn left 90 degrees. In order, list the instruments you will scan while A, rolling into the turn, B, maintaining the turn, and C, rolling out of the turn. Many questions, but it's not a big deal. If you want to be professional and good trained pilot, you must do it so quickly. I hope you manage all. Okay? Nice. I hope you enjoyed this lecture, and I'm looking forward to seeing you next time. Okay? Bye. See you next time.